Here is where we left off. We had found a free body diagram of the left foundation and the right foundation. And now we're going to move to the middle of the building and look at that center floor beam. That is this thing in the middle here. There's a lot going on here because it's got 3 columns that it has to hold up. Those columns go all the way up to the roof. Then it's got the distributed load from the flooring, the joists in the floor. And then it's got these 5 support posts underneath. So first, let's think about our distributed load. Here at the bottom of the slide is a repeat of the free body diagram of the joist that we did earlier. And what we notice here is that, and let me just point out again, here's the joist in the lower left corner of the slide. It's at right angles to the floor beam, which is in the upper corner of the slide. All right, so this joist in the lower corner, we found out that the support there at the floor beam was 1248 pounds. And that was for a 2-foot wide strip of floor because the joists are 2 feet apart. For a 1-foot wide strip, 1 foot of weight on the floor beam, we'll just divide that 2-foot load, divide by 2, and our load is going to be 624 pounds per lineal foot. So here is the beginning of our free body diagram of our floor beam. Here's our floor beam. And I have written 624 pounds per foot above this distributed load symbol. That's what we just figured out. That's the distributed load on that beam. Now let's figure out what's happening with these columns up here. And those columns, here they are in the exploded view, those columns support the roof beam, don't they? So we could turn to our free body diagram of our roof beam to figure out how much weight was on each of those 3 columns. And here's our free body diagram of our roof beam, and this is what we found. That the 2 outside columns have a load of 2574 pounds, and that middle column has a load of 5148 pounds. Okay, and that has to get translated all the way down to that floor beam. So here those numbers are added to the free body diagram of the floor beam. So we've got numbers for the columns, we've got the distributed load for the floor, there's the beam itself, and now we're going to look at the reactions for the 5 posts underneath. So here's the floor beam going front to back, and I've drawn a top, front, and side view, or whatever you want to call this view, so that you can see those 5 posts there. Now let's review what we know about the floor load. I know we've been over this before, but we need to remember. The live load, he told us, was 40 pounds per square foot, and the dead load of the floor plus the joist was 5 and 3, so the total load on the floor is 48 pounds per square foot. That's what he gives us. Okay, so these posts underneath are 6 feet apart. That means that from the outside to halfway to the next post is 3 feet. So here in the top view, the plan view, here is our tributary area that's being of floor that's being supported by that outside post. It's 3 feet wide and 13 feet deep. What's 3 times 13? 39 square feet is the tributary area. And that tributary area of 39 square feet supports 48 pounds for every square foot. So multiplying those numbers, you find out that comes out to 1872 pounds sitting on that outside post. So let's return to our free body diagram of our floor beam. We're thinking about our outside posts. We just found that they're supporting 1872 from this floor business. But remember, they also support 2574 pounds that are coming down from that column. So underneath this floor beam, we've got the load of the column plus the tributary area of the floor. So we've got 46 pounds at the end post at each end of that floor beam. Now let's move to the next, call it the intermediate post. Not the outside, not the center, but they're in between. Here they are. In the, whatever you call it, this side view, we can see that those posts are 6 feet apart, so that tributary area is 6 feet wide. Here's a plan view of that tributary area. 6 by 13 is how many square feet? It is 78 square feet, and each one of those 78 square feet is carrying 48 pounds. 48 pounds per square foot. So 78 times 48 gives us 3744. Now turning again to our free body diagram of our floor beam, we can just write 3744 on our diagram because that's the only load here. There are no columns coming down from above to complicate things. It's just that distributed load from the floor and joists, 3744, on each intermediate post. There are those intermediate posts. Okay, how about that center post? One in the very middle. Here's its tributary area. Again, the posts are 6 feet apart, so that strip halfway on each side is 6 feet wide, or deep, I guess. Anyway, that tributary area is 6 feet by 13 feet. So there's another 78 square feet of area times 48 pounds per square foot. That area weighs 3744 pounds. And so that's coming down on that center post. But remember that that center post also holds up the load from this center column up above. That center column is 5148, and then we just figured out that that post has another 3744. So when we add those two together, the column and the post reaction, we find out that that center post right there is pushing up, is holding up 8892 pounds. And that makes that one center footing there the critical footing that we want to look at. As we're figuring out, is our soil capable of holding up this load? Notice these other footings and posts, they have weight on them, but the weight is less. It's that center one that's really heavy. So let us think about that. And our book says, consider a footing that is 2 feet by 2 feet. It's a square chunk of concrete, 2 feet on each side. All right, question. How many square feet are in a square that's 2 feet on a side? Well, if it bugs you to think about that, you can draw a picture, which is what I did here. So each one of these squares is 1 foot, and without doing a lot of math, you can just count them. 1, 2, 3, 4. There are 4 square feet in that 2 by 2 square. And that is the footing that is holding up that's that critical footing that is holding up that big old weight of 8892 pounds. So question, how much weight is on each square foot? If this pad is 4 square feet and that 8892 is distributed over those 4 square feet, to find out, we divide 8892 by 4. 8892 divided by 4 gives us 2223 pounds per square foot. And our book tells us that the soil capacity is 3,000 pounds per square foot. And you might remember that from our opening slide where he gives us that. In other words, 1 square foot of soil can hold up 3,000 pounds. Question, is it adequate? Well, it's capable of holding 3,000. It's only got 2223 on it, so yes, that is going to be okay. Now, the book has neglected the weight of the concrete, but what if you wanted to be particular and you wanted to add the weight of the concrete in? Typical concrete weighs 150 pounds per cubic foot, so let's just roughly estimate this footing here, this pier block, might weigh about 600 pounds. So if we've got 8892 pounds coming down and we add another 600 pounds for the concrete, we wind up with 9492 pounds sitting on that piece of soil. Is that okay? Well, remember that we've got 4 square feet of concrete area here, so let's divide 9492 by 4. We'll get 2373 pounds per square foot. Each square foot of concrete pad is holding up 2373. Is it adequate? Yes. The soil can hold up 3,000 pounds per square foot. We're only dealing with 2373 pounds per square foot, which is less. That's a lighter weight. So we are good. And there you have it. You have made your way all the way down from the roof of this thing to through the foundation to the soil, and that is it. Our load tracing is done.